Welcome to the introductory video to the project. Be a Cartoonist, editing anime images using generative adversarial networks. The aim of this project is to firstly, translate human face to an anime face, perform image editing without using image editing tools or software, perform model compression to reduce the computational power and size requirement of our model. First, image-to-image translation. Image-to-image translation is the process of translating an image from a certain domain into another. It is used in many applications such as translating an image from a zebra to a horse, a cat to a dog. There are few works that exist that deal with translation of human faces specifically into Japanese anime style face. We could simply use existing architectures to attempt to achieve our objective, but there are some existing problems. First of all, the identity of the original real face is not maintained after the translation. Secondly, artifacts appears on the translated faces. Lastly, the quality of the translations is simply too poor. To combat all these problems, we propose the use of our architecture, a feature-based multi-discriminators. In our architecture, instead of using a single discriminator to directly perform prediction on the whole face, we slice the face into different facial features. The facial features are the mouth, the face, the nose and the eyes. Both generated and ground truth images will be sliced during training into these individual features, and the corresponding discriminator will perform its prediction. We can see from the result of our architecture that it performs significantly better during translation as compared to the other existing architecture that is trained on the same anime dataset. In our training pipeline, using landmark-based detection algorithm, we perform face alignment and cropping on the images of the anime dataset to align it to the likes of the FFHQ dataset. We've also filtered through and removed images of poor quality. We also start training from a pre-trained 256 by 256 resolution style Gansu model. During inference, we perform layer swapping at lower resolution layers to retain the structure of the source domain while using the target generator's higher resolution generator layers. This interpolation will help our final generator images retain the structure of the source domain images while having the looks and feel of the target domain images. In image editing, we employ closed-form factorization. Existing works have shown that style Gansu model can be evaluated and interpreted at the following layers shown on the diagram: the top layers, the middle layers, and the bottom layers. They affect varying styles of facial features. It could be painting styles, the eye size, and the facial pose. We then learn semantic directions and modify them to alter the respective features of the image. Using this technique, we can alter facial features such as the facial pose, expression, and hair color. We can see from our example here where the facial expression, the facial pose, and the hairstyle has been modified. Lastly, our last objective is to perform model compression to reduce the computational requirements of our model through the use of knowledge distillation. In knowledge distillation, there exists a pre-trained teacher network and a student network which we hope to distill the knowledge to. In our experiments, we will use a network with reduced channel as our student network. We first train a teacher network and use the trained network to perform the knowledge distillation using mimicking losses. We use perceptual loss and the L1 loss on the generated images of both the student and teacher generated images, as well as use the trained teacher discriminator, which is already embedded with the knowledge from its previous training, to train the student generator. To make a comparison, we trained a style Gansu model using a normal adversarial training but with reduced channels and record its FID score. We can see that our compressed model has a lower FID score, which means that its generated images are slightly better in quality than the one trained normally. Our model performed close to the original model as well, but we can see that we have a significantly reduced multiply accumulate operations at 1.8 billion as compared to 14 billion due to the reduced number of channels. To conclude, we came up with an image-to-image translation model capable of performing high-quality translation of real faces to anime faces. We perform image editing without the use of image editing software and tools by employing closed-form factorization. To reduce computational requirements of our model and its size, we perform knowledge distillation to train a smaller model with reduced channels without compromising much on its performance. Thank you for watching the introductory video to the project Be a Cartoonist, editing anime images using Generative Adversarial Network.